Hey BrainBooster family! Welcome to part 8 of our system design series. In this video, we're diving into chapter 8, Design a URL Shortener from System Design Interview, an Insider's Guide by Alex Su. Let's break it down step by step. First, what's the problem we're solving? The idea is pretty simple. You take a long URL like example.com/blog/2025/designing a URL shortener, and you turn it into something short and shareable, like short.ly/abc123. Now, whenever someone clicks that short link, they should be redirected to the original long URL. So the system should support two core actions: generate a short link for a long URL, redirect that short link to the original one. Next, let's estimate the scale. Let's say we're handling around 100 million new URLs every month. Since most people just click links rather than create them, the system is read heavy, maybe 10 reads for every write. Also, if each URL mapping takes about 500 bytes, storing 1 billion URLs would take around 500 gigabytes, not massive, but something to plan for. API design. We'll need two simple APIs, one for shortening, post, shorten body, long_URL, https:// and one for redirection. This finds the original long URL and redirects the user, get short_ID. How do we generate short URLs? There are a few ways to do this. 1. Auto-increment ID plus base 62. Encoding this is super common. Just take a number like 125, encode it in base 62, and you get something like CB. 2. Hashing the URL. You could use MD5 or SHA-256 to generate a fixed length ID. But there's a risk of collisions, i.e., two URLs giving the same ID, so you'll need checks in place. 3. Random strings. Another option is to just generate a random 6-character string and make sure it hasn't been used before. What does the database look like? We can keep it simple with a URL_mapping table, short_URL_ID, something like ABC123 long_URL, the original full URL created _ at, timestamp expiry_time, if we want links to expire after a while. The system components. So here's what makes up the system: web servers to handle incoming requests, app logic to generate IDs and redirect, database to store the mappings, a cache like Redis for fast lookup of popular links, and maybe even an analytics service if you want to track clicks. How do we make it perform fast? There are a few strategies. Cache popular links in Redis so we don't hit the DB every time. Shard the database by short URL ID to avoid bottlenecks. Replicate the DB so reads can scale. How do we keep it available? Use a load balancer to distribute requests. Set up DB replication, one master and multiple slave. Build a failover mechanism so the system doesn't go down if one server fails. What about spam and abuse? You don't want people turning your platform into a phishing hub. Rate limit how many links a user can create. Validate that the submitted URL is real and well-formed. Blacklist sketchy domains. Security considerations. Make sure your redirects happen over HTTPS. Let users set an expiry time for links. Don't allow bad words or malicious phrases in custom aliases. Optional features you can add. If you're building a commercial-grade URL shortener, you can also offer custom aliases, like short.ly/mybrand. Click analytics. Track how many people use the link. QR code generation. Expiring links. Links that auto-delete after a set time. Real-world example. Let's say a user sends a post request with their long URL. We generate a unique ID like ABC123, store the mapping in the DB, and return the short link, https://short.ly/abc123. Now when someone visits that short link, we look up ABC123, find the original long URL, and redirect them. Simple, but powerful. Designing something this simple yet scalable takes careful planning of IDs, databases, caching, and abuse prevention. Thanks for watching, BrainBooster family. Don't forget to like, share, and subscribe if you're finding this series helpful. Catch you in the next part.